My name's Adam. I'm the product manager for Vector Search.
And hi, I'm Ankit. I'm the tech lead for Vector Search.
And we're going to talk about going beyond simple RAG to large-scale, high-quality, fresh, and cost-effective retrieval systems. We've talked to hundreds of customers just over the last year. Some of them are in the room today. It's good to see you guys. And so we're going to start off by sharing the typical journey that we see when customers try to go beyond simple RAG. Then we'll talk about the first steps we took towards making that journey better back when we released our first product back in 2003 by making index creation and freshness way, way easier. Then we'll talk about what we've done over the last year to solve even bigger problems around quality and scale. And we'll do a deep dive to share some of the key insights about retrieval quality and how best to think about it. And we'll get into a demo of doing a total end-to-end demo of building a super high-quality agent on a massive proprietary data set. And finally, we'll finish up by sharing, what's next for Vector Search. So before we get into it, just have to say, this is for informational purposes only. Our roadmap is constantly changing as we learn from customers like you guys. Okay, so I'm going to tell you guys a story of a typical customer journey of going beyond simple RAG, and you guys will tell me if any of this sounds familiar, okay? So meet Alex. Alex is an engineer at Brick Corp, a big consumer electronics company. And she was tasked with building an AI assistant for the customer support team to help them resolve customer support cases more quickly and more accurately. And so starting with just the robot vacuum product line, just one of her product lines, Alex set up a vector database to create a POC for her RAG chat application that could answer questions from previous cases and their resolutions and product manuals. And with all the open source tech out there that's just available online, this was actually really easy, and it was actually pretty fun. But then she had to create a pipeline to compute the embeddings. And she needed to have that pipeline ready to compute embeddings not only on new cases and product manuals, but also on queries that were coming in real time. And then it turned out that computing embeddings wasn't the only thing that this pipeline needed to do. It also needed to insert vectors into a vector database. And if anything got added or changed in the product manuals and cases, she had to implement even more custom pipelines to make sure that the content in the vector database was actually consistent with what needed to be there. And this took her a few weeks, but she was finally able to get this done. But then she got to user acceptance testing. And it turned out that quality just wasn't good. And regular vector search wasn't helping in situations where the customers had an exact error code that they needed to look up. So she spent all this time configuring a hybrid search, deploying a re-ranking model, wrapping her calls to the vector search so that they could be re-ranked. And this took another few weeks, but she was finally able to get it done. Quality was good. It was time to go to production. All she needed to do was just get the cases and product manuals for the company's entire product line into the vector database, and she would be good to go. But as she started to put more and more vectors into the vector database, things started getting expensive and really slow. And she started spending more money and more time manually managing the infrastructure needed just to get the vectors into the vector database. And now she was on call every time something broke with one of her custom pipelines or one of her custom re-ranking systems. This was definitely not fun anymore. So did any of that resonate with anybody here? Show of hands. Okay, got it. Maybe somebody over here was raising their hand. Maybe Alex. Which part of that was familiar to you guys? All of it was familiar? The re-ranking systems, I know Alex. So the re-ranking system is something with Alex. Anybody else thought that part of it was familiar to them? Okay, yeah, we've been seeing customers implementing their own re-ranking systems. It's a pain to manage the models, the wrapping. We're definitely hearing that. So these problems are very familiar to us at Databricks. And today we're going to talk about how we're solving all of these problems. And I'm going to hand it over, and how we transformed this very painful journey into a, not trying to toot our own horn here, Ankit's the one who actually built it, into a beautiful product experience where you can make a super scalable, high quality vector index without the crazy costs and without all that custom code and infrastructure management. So now I'll hand it over to Ankit to talk about how we did it, starting from the beginning.
Awesome, thanks, Adam. I'm going to give a brief overview or a recap of what Mosaic AI Vector Search is before we deep dive in some of the exciting things that we've been building the past year that we're very excited to share with you folks. So we launched Mosaic AI Vector Search in 2023 with the core philosophy of simplifying search on the lakehouse. So you give us a delta table and we will give you a search index and manage all the complexities that involve in building that search index. That involves ingestion pipelines that need to do embedding generation, need to look up for changes on the delta table and then ingest it into the vector index so that all the problems that Alex was facing, that Adam just described, you don't have to face them anymore. It is simple and fully managed from both an ingestion as well as a query standpoint. And traditional vector databases usually have a vector in, vector out interface, but we want to change that. We want to give you a text in, text out interface so that you don't have to worry about any of the complexities that goes into building or serving an index. You only care about searching. It is scalable and performant, and we have seen a variety of use cases being used at scale, and we are able to see performance with various different use cases that customers are playing around with. And it has deep native integration with the Data Intelligence Platform and other search AI systems on the platform, such as like agents. Like you can create vector search, register it as a tool on the agent, then evaluate the agent using the agent evaluation framework, all while having built-in governance using via Unity Catalog. And we've seen great adoption. Customers have rapidly adopted the product, and as of May 2025, we've seen tens and thousands of indices being served live on the platform, and thousands of customers are using vector search on a daily basis. Now, I just wanted to give you a perspective of what customers are using vector search and what are they productionizing it. The most common use case is the RAG. It's nothing but you retrieve data from the vector source and give it to the LLM as context so that it can summarize. So good examples of this would be real-time chat applications, which is the most common one. You can also do like batch investment report generation, and automatic root cause analysis are also like categorized as a RAG application. But there are interesting use cases that customers are also building. One such use case is matching. A matching use case is where you're trying to match a query to a set of similar entities. Like examples of this would be you're matching job applicants with job postings, you're trying to detect malware using similar old binaries, or you're recommending similar items for shopping, for example. And the third use case that is more common is the traditional search use case, where you have a search bar, example, and you want to search for it, give the results back to the user, which are the most relevant ones. So in-product searches, assembling high-quality data sets, and searching across a lot of communications for like audit purposes comes under these buckets. Now, we did provide a simple, fully managed solution that was scalable and performant, but we started getting feedback on quality and scale, especially when customers started to use the product more and more, and they had use cases that were pushing the limits of our or boundaries of our product. So on the quality side, we saw that there was a need for more quality. And the way that they were building it was deploying their own reranking solutions, which is also complex in some way, but it is also an operational overhead which now they have to maintain. So they were literally asking us to provide us with more out-of-box quality so that they don't have to manage any of this infra from themselves. And when it comes to scale, they started realizing then as and when they wanted to ingest more and more vectors, they often started hitting limits of the system. And to circumvent that, they could either split the data into multiple endpoints so that now they can get away with the limits that we have, or they soon realized that at that scale, it was getting a lot costly than they had hoped for. So we improved out-of-box quality with a hybrid search and re-ranker. Like hybrid search is out of the box, which we released last year. And it really helped customers to do semantic relevance with keyword precision. But for customers who wanted even better quality, they were still maintaining their own re-ranking systems. So we worked closely with the Mosaic research team, which are total rock stars, by the way, and built a fast, state-of-the-art re-ranker that can improve the relevance of your search results while providing better quality than state-of-the-art cloud competitors out there. This is coming soon in the summer. It is still in private preview. But how does a re-ranker work, and why does it provide with better quality? So we should take a step back. So a traditional vector database works on embeddings. So when you embed something, you would often lose some signal. And when you lose that signal, even though the initial results that you get from a vector database might be good enough, but for customers who really want high quality, they have to do something else. And that is where a re-ranker shines. A re-ranker is nothing but a bigger model, and it works directly on text, and it would provide you with better ranking so that all the signals that got lost in the embedding generation does not happen when you're doing this re-ranking step. But what's the catch? The catch here is that it adds latency to your retrieval step, and I'm going to talk about some of the retrieval quality trade-offs in a few minutes. And for solving scale at low cost, we are very excited to announce our new offering called Storage Optimized Endpoints. This is a new offering that is in public preview and is ready to use. It is a completely re-architecture of our current offering, and with storage compute isolation that allows us to solve some of the most challenging scaling problems out there in cost-effective manner. In one line, if I have to tell it, it's the same API that you're used to, whether it's from the Python SDK or whether it is from the REST API, but with a brand new backend that we are managing to provide you with scale at low cost. But what does it actually mean to you as a user? So there are three parts to it. So the first part of it is cost. It is 7x cheaper than our current offering. It can now scale into billions of vectors, so you don't have to worry about splitting your data or worrying about how much to store there. And on top of it, it has 20x faster ingestion. So now you can develop faster, but at the same time, you can also upgrade production very quickly. But what's the catch again? So the catch here is there is a trade-off that we had to do on the latency side to provide you with all these benefits. It adds about 200 milliseconds of additional latency, but we are really working towards improving that down the road. But what we have heard from most of the customers that since they have an LLM in the retrieval step, this additional latency does not affect them as much, and they can still use this to get all the other benefits because their LLM is still going to take the most amount of time. But one key takeaway is if you have latency sensitive searches like in product search or recommender systems, stronger consideration still needs to be taken while adopting the storage optimized endpoints, and the standard offering might still be a better fit for it. And customers are really happy with preview. We have Alex here from PSP Investments who mentioned that storage optimized vector search is their next generation vector search. It is way more scalable and fast and is really helping them build their AI investment analyst assistant quickly. Now, before we go to the demo, we also wanted to share a retrieval quality playbook. So we have talked to hundreds of customers, and these are some of the recommendations that we feel would really help to improve your retrieval quality. But let's talk about what is retrieval. So retrieval in one line is nothing but getting the most relevant information for your task. So for a RAG chatbot, this could be the most accurate context that you have to give to the LLM. For a matching system, it needs to be the closest entities, and for a search system, it needs to be the top results that the user would see. So the first takeaway that we have is use hybrid search when you need both semantic relevance and keyword precision. But how do we know you need this? A good way to think about is whenever you have domain-specific vocabulary, use hybrid search. The reason for this is embedding models often are not aware or do not have the context on your domain-specific vocabulary, so they might not give you the most accurate results from just semantic relevance. And this is where hybrid search shines. Like it would use best of both worlds, fuse the results, and give you the top results so that you don't have to worry about this. And luckily, this is all built in. All you have to do is turn on the feature or choose a mode during your query time, and you can improve your quality from the get-go. Now let's talk about reranker, because this is something a lot of customers are building on their own before we introduced our own. So just a quick recap. Like traditional vector databases work on embeddings. And whenever you embed something, there's possibility of losing signal, so it might not give you the best results. So reranker works, it's a bigger model, works directly on text, would provide you with better ranking. But the trade-off here is there adds latency to your search retrieval. But for customers who are really sensitive to quality and they want the top quality and they are okay with slight increase in latency, reranker really shines. And that is true for most of the customers that we have talked to. Because they have an LLM in their retrieval step, it usually is the most time-consuming step. But for latency-sensitive applications, the stronger consideration still needs to be given before adopting a reranker. Now let's talk about evaluation. Like we feel consistent evaluation is the best way to iterate on quality. Now what we have seen from customers is like a lot of customers struggle during evaluation because they're doing everything manually and mostly via vibe checking. Now, vibe checking can only take you so far. Like let's say you change something, a setting in your system that is expected to increase quality. But how do you prove that it increased quality? So in that case, vibe checking is not the right solution, and we want you to think of it in a more automatic fashion so that you don't have to worry about when some setting is being changed and how does it affect quality. So the first recommendation is automate the process, and with Databricks agent evaluation. It really helps to make to iterate this whole process better, and at the same time give you that quick feedback that you're looking for whenever you are improving quality. Now let's say you don't have an evaluation data set, or you don't have the time, or it's tough to create one. We still have other tools that you could use on a system. Like you can use a ground truth free judges or synthetic data generation APIs to get started with quality. Now to summarize the quality retrieval quality best practices, the first is hybrid search. Use hybrid search whenever you have domain specific vocabulary. This is out of the box and should be used to just improve your quality on the get-go. Use reranking when quality is of the highest importance and you're okay with sacrificing some latency, and this is coming in summer. And finally, consistent evaluation. Use Databricks agent evaluation and ground truth free judges or synthetic data generation APIs to iterate on your quality. Now I'm going to hand it over to Adam to show how it all works. How Alex can create and evaluate a high quality search agent on a billion vector database for her customer support reps.
All right, thank you, Ankit. So let's dive into the demo. What we're going to do today is we're going to start by creating an absolutely massive vector index over the customer support tickets and their resolutions. We're going to take that index and use it to create a data intelligent agent that can use that index to help the support team answer and resolve new customer cases. We'll run an evaluation of that agent with multiple retrieval configurations like hybrid search and re-ranking to get a much more high quality agent. And finally, we'll give you guys a sneak peek of a super secret feature that only you guys are going to know about for the time being, which is our full text search capability. And we're going to show you how we can create a search agent for the support team that can even help in customer cases where there's a super specific error code that needs to be found. But first, I'm going to show you our end state for the demo today. So I'm in Playground here, and I'm going to select our data intelligent agent that can answer questions over previous cases right here. And I'm going to ask it a question. I'm going to ask it, my customer is saying they're getting an error, like system internal error 002 on their smart speaker. How do I help them? So remember, this is actually not simple RAG. Behind the scenes, this agent is using an absolutely massive and automatically updating vector search index to answer this question. And there's hybrid search, re-ranking, and full text search going on in the background to answer this question. So it looks like it already answered the question. That was fast. So great. It retrieved the document that has that internal error. I can provide you with information on how to resolve this error. So they just have to restart the smart speaker and make sure the phone is closer to the smart speaker. And we can even see the documents that are retrieved. Okay, yeah, so the resolution summary actually was to restart the speaker and bring the speaker close when they were having this error code. So we can tell that this response was grounded. So this is our nirvana state. Let's figure out how we actually get to this point. So what we're going to do first is we're actually going to need to create that massive vector index that the agent can use to answer these questions for the support team. So I'll switch back over and go to Alex's Delta table. So this is Alex's Delta table of previous customer support cases and their resolutions. Now note that this is over 1 billion records. And so if I go into sample data here, we can see that each row is a previous ticket with its ID, it's about a specific product, and it has an error code. In this case, the description of this ticket is, looks like the doorbell cam was having some sort of authentication issue in this case. We can see this resolution summary. So in this case, for the doorbell cam, they just have to reset their password and verify their auth settings. And there's some tags here, there's some other information, but most importantly, we're going to have a column here that's the description and the resolution in one column, and this is actually the column that we're going to use for our retrieval. So for Alex to create her AI assistant for the support team, she's going to need to create a search index to retrieve over these cases that we're looking at right now. So all I'm going to do here is go to create and hit search index. And so for the name of it, I'm going to name it something like consumer electronics index. For the primary key, I'm just going to select the ticket ID. If you check the tooltip, it just says that this has to be a unique column that you have here. And for columns to sync, I'm actually just going to leave that blank. This is going to now allow me to retrieve all of the columns at retrieval time, not just a subset of them that I select. So I'll just leave that blank. And then for embeddings, now notice that I can actually click skip embeddings here. This is part of the super secret sneak peek that you guys are getting today of our full text search offering. So what we're going to be enabling people to do is just create a pure full text search index without having to compute embeddings at all. Or in the case that they are computing embeddings, they'll be able to query that index with just a regular keyword search paradigm. And we'll show you how to do that in a few minutes. So I'm going to select compute embeddings. For the embedding source column, I'm going to select that description resolution column that contains the description of the issue and the resolution of the issue in that one column that we can embed and retrieve over. For the embedding model, I'm just going to select GTE large. This is a high quality model that most of our customers are using right now, and we offer it out of the box. Now, finally, I have to select our vector search endpoint. So I'm going to go in here and I'm going to select customer support endpoint. Now, I'm going to backspace here. As you see, all these endpoints over here are standard, but this endpoint is going to be a storage optimized endpoint. So that's all you need to do, basically, to get that billion vector scale, that super fast indexing, and that way cheaper cost, is literally just select storage optimized endpoint for your index. And I'll hit create here. Now, for 1 billion vectors, it can take about 8 hours to create an index. And while this is literally world class, I'm not going to force you to sit here and watch that happen. I'm just going to go to one that I've already created in advance for you guys. So I'll switch over to my index. So this is my vector search index. Now, looks very similar to the table. This is just, it's also a Unity catalog entity, and it's actually linked to the table we created the index from. So what that means is when new tickets and customer support cases end up making their way into that table, they'll automatically get embedded and ingested into this index whenever a sync is triggered. So there's literally zero embedding and ingestion pipeline management needed for Alex in this case. And notice that this is an entity in Unity Catalog. I can do the regular things I can do with entities in Unity Catalog. I can go to permissions here. I can grant permissions to whoever needs to be able to access this index. It's just a regular Unity Catalog entity. So we successfully created our index. Now that we've created the index, it's time to create the agent that can actually use that index to help the customer support team resolve new cases. So I'll switch over to Playground here. Now, I'm going to select Claude 3.7 as I know it's a pretty good model, not as good as Claude 4, but I'll select Claude 3.7 for now. And I'm going to add our vector search index as a tool. Oops, I have to select vector search. Okay. And then I'm going to ask it the same question that we asked the Nirvana agent before. My customer is saying that they're getting this system internal underscore error 002 on their smart speaker. How do I help them? And so behind the scenes, the agent is going to decide how it's going to answer the question based on the tools that it has available. In this case, only our vector search index. And it's going to create and execute a query against that vector search index, take the results of that query, and pass it to Claude 3.7 Sonnet to actually answer the question. Now, spoiler alert here, it's probably going to retry a bunch of times, and we're going to be looking if it's actually able to answer this question in a grounded way. Because, since this is just a regular vector similarity search, it's highly unlikely it's going to be able to find the ticket with this super specific error code that we're looking for, since the embedding model has likely never seen that exact error code in its training data. So it looks like it finally answered. Let's see what it came up with. Okay, yeah, the AI judge is already telling us this is not grounded. So it tried a bunch of times. It's telling us, yeah, the exact error code doesn't appear in our database. That's a hallucination. It's definitely in the database. It just wasn't able to find it. And if we scroll down, the AI judge is telling us this is just not a grounded answer. So the error code appears on smart speakers, but the retrieved context describes a similar issue, and the retrieved context does not specifically mention that error code. Okay, so this was a hallucination. And so it answered the question, but Alex is going to need to figure out how to improve this. She's going to need to figure out how to understand the quality of this agent. How good is it? She's going to need to be able to systematically evaluate it and then figure out if she can improve it. So that's what we're going to do. Now that we've created this agent, we're going to have to improve it. So we're going to run an evaluation, comparing a few different retrieval configurations, including hybrid search and re-ranking, to try to make our agent better. And so with the release of our re-ranker this summer, we're going to be providing an out-of-the-box notebook that just does that for you. It basically helps you automatically evaluate and different retrieval configurations for your use case. And it's going to generate agents against that evaluation set and evaluate them against them for whatever retriever configurations you want to test. So basically all I have to do is fill out the first cell here and then just run the notebook and it'll just do it for me. So in this case, I just had to provide my source table. I had to provide my vector search index. I had to provide my ID column. And I also had to provide an LLM that I'm going to use as the LLM that powers the agent. And then I just had to give the agent a description so that it knows what it is, so it can actually execute the task. So I just told it that it's a RAG chatbot designed to help customer support agents answer questions, etc. And then for the synthetic data generation, I need to provide some example questions to help guide the synthetic data generation. So, what are questions that these support agents might be asking? How do I fix an auth issue for the doorbell cam, or the customer says the smart speaker isn't turning on, or the router pro is blinking? Those kinds of things. Now, most importantly, let's look at the retriever configurations that we're going to test today. So we're testing two retriever configurations, the top one against the bottom one. Now, they're both going to be retrieving 10 results from the vector index, but notice that the query types are different. So in the first one, we're just going to be evaluating the naive implementation that we just tested, basically, just using ANN. ANN is approximate nearest neighbors. This is just standard vector similarity search. And in the bottom one, we're going to be testing our hybrid search. So this is going to help us in situations where there might be domain-specific vocabulary, let's say a specific product name, or hopefully a specific error code. And so I've also added columns to re-rank here, which is going to enable our re-ranker. So our re-ranker is now going to be able to look at this column, the text column that we've provided, and hopefully even boost the quality even more. So generating the synthetic data, running the evaluation with the LLM judges, this can take a few minutes. I've already ran it in advance. Literally, once you run the notebook, you just get this beautiful eval UI that we're actually really proud of here. So let me show you what it looks like here. So we're evaluating the green dot, which is the mature implementation that has hybrid and has re-ranker with top 10 results, against the blue dot, which is this naive implementation that we started with, which is just the typical vector similarity search. And we can see that just by enabling hybrid and re-ranker, we were able to boost precision and chunk relevance by 24 points. We were able to boost context efficiency which is another really important metrics for LLM judges, by 29%, and we were able to increase groundedness by 21%. So this is huge. We already have a much better configuration in just by running this notebook. So now that we have this better configuration, let's take a step back. We've done most of the work here of creating a super high quality agent, but we want to show you a sneak peek of how we can make it even better. And so we're going to show you our full text search. This is going to help our customer support team resolve tickets where there's a very specific error code even more quickly and accurately. So I'm going to switch over to a notebook here. Now, as we see, I'm querying our index here for this very specific error code, but I'm using the query type ANN, so I can run it. And as we've seen multiple times, unfortunately, ANN is just not cut out for this. ANN is just a regular vector similarity search using an embedding model, and that embedding model has definitely never seen this error code. So if we look at the results, yeah, this has literally nothing to do with the error code that we're looking for. So what we can try is, I can try to switch my query type to hybrid. And this actually might work. This might help. So I'm going to try that. So we can try hybrid search, and it's possible that it'll help, but it's doing both keyword search and ANN at the same time, and then fusing the results. So even if it does work, let's see if it does. Okay, in this case, it didn't even work. But even if it does work, there's going to be noise mixed into the results from the regular ANN. So if you're searching for this super specific error code, all you care about is that specific error code. You don't care about doing a similarity search against that error code that the embedding model has never even seen before. So recently, as customers have been moving beyond simple RAG, this is what they've been asking for. They're starting to see a need for keyword precision without the noise of ANN in their similarity searches. In situations just like these, where the keyword is literally the only thing that matters. So we've just added a full text search option. So all you need to do is just change your query, same API, just do a full text search query, and we get the results that only correspond to this specific internal error. So this is huge for us. The results are good now. Let's see what the agent looks like that can actually use this. So let's switch over to the playground. So once again, we're going to select the naive implementation, which is just calling ANN on our vector search index. And we're going to do a comparison side by side with our super special secret hybrid search and full text and reranker agent that we saw at the beginning. And we're going to ask it the same exact question. My customer is getting this super specific error. How do I help them? Now, behind the scenes, once again, the agent on the left is our naive agent. So it's just going to call the vector search agent with regular similarity search, and it's probably going to hallucinate just like it did before. The agent on our right is our new agent that can use full text search, hybrid search, and our reranker to get the best possible answer for the support agent. To be completely fair, neither of these are simple RAG. They're both backed by a massive and automatically updating vector index, but our agent to the right is just taking it to the next level in terms of quality by using all of our capabilities to the max, like hybrid search, reranking, full text search. And as we see, the agent on the right has already completed, and it's answered the question. Let's see. Yeah, so it retrieved the document that has that error code. Restart the speaker, bring it closer, as we saw before, that's the resolution. And this one took a while to answer. Looks like it retried like 5 times because it couldn't find anything that had to do with that error code. And in this case, it didn't even retrieve anything with that error code, but it's just hallucinating an answer. So as we see, the agent on the right is able to resolve this case for our customer support agents, and the agent on the left is it's too naive and it's not going to help them. So we've been able to go through this quality loop together and get something that can help our support agents. So let's take a step back here. That's our demo. We started with our massive data set of previous support tickets and their resolutions. We created a very large scale index to be able to retrieve from that set of support tickets and their resolutions. Then we created this kind of basic agent that could use that index to help the support team resolve new cases, but it just wasn't enough. We wanted to make it super high quality. So we ran an automatic eval with synthetic data generation to see if our out-of-the-box hybrid search and reranker would actually help the quality. And they really did. And finally, we gave you guys a sneak peek of what's coming soon, which is our full text search. We showed you how Alex can make the agent handle these edge cases where the customer is expecting or is experiencing a very specific error code, and it was able to answer the question perfectly. So you might be wondering what's coming next for us in vector search. Well, we're coming soon with this full text search capability that we previewed to you guys today. This is going to be regular, large-scale keyword search with functionalities like filtering and faceting. Now, we're releasing even more capabilities around cost management, including things like scale to zero capabilities to reduce your costs during development, and all sorts of budget policies and tags to allow you even finer control and visibility into your costs. Now, some customers have actually been really pushing the limits of our system in terms of load, so we're actually going to be introducing some native support for high QPS use cases. So this means no more creating multiple endpoints and load balancing across them. We're going to have a native solution for this. Now, we're also working on more governance capabilities. For example, when your users are chatting against your knowledge base, it's probably best that they can only get answers to data that they should have access to. And right now, customers are kind of implementing this themselves using our filtering capabilities. So we want this to be a more native experience to do row-based access control for your vector search index. And finally, we're working on rank boosting. So you can boost results on attributes like recency, for example, to make sure that we're taking into account that the most recent docs might actually be more relevant in your use case. So we covered a lot today. Let's do a quick recap. We went through the typical journey that we see customers going through when they depart their naive, simple RAG applications. We went through how do we make that journey a whole lot easier on Databricks, starting from index creation and freshness to quality, scale, cost. We gave you some insider tips about retrieval quality and how best to think about it, including when to use hybrid search and re-rankers. And we showed you how it's done and created a super high quality agent to retrieve from our massive data set of customer support tickets. And finally, we shared the roadmap. So thank you so much for coming today, guys. We really appreciate it. If you want more resources, we're going to be sending out a bunch of resources. Or if you want to get in contact with us on some of those roadmap features for private previews, definitely scan this code and just fill out which private previews you're interested in participating in. And we'll be in contact very soon about getting you guys into those private previews. So everybody scanned? Okay. Thanks so much for coming today, guys. We really appreciate it.